the dark energy camera.
We want to understand dark energy as best we can. We need to gather as much information as possible.
This sensor has an incredible 520 megapixels. Each one, chilled by liquid helium, is capable of picking up particles of light that have traveled across the universe for billions of years.
We're going deeper than other cameras have in the past, so we're measuring stuff further back in time, and also doing it quickly with this big camera.
The dark energy camera will be able to cover huge swaths of the sky in a single night, and will keep on doing so for 5 years, slowly building up more detail in its images, searching for clues about how dark energy has evolved as our universe has evolved.
Right now, the information that we have about dark energy is that it's getting stronger and stronger, and the universe is expanding faster and faster. And we don't know why. And since we don't know why, we don't know what comes next. We want to take these deeper surveys to try to understand that.
The hope is that these surveys will reveal our universe's future by looking back at its 14 billion years of development in unprecedented detail. As best as scientists understand it now, dark matter was the dominant force in determining the form of the universe in its first 7 billion years. It was dark matter, after all, that allowed galaxies to form, attracting regular matter with its invisible mass. In its second 7 billion years, dark energy grew, overtook dark matter, and now seems to be winning the cosmic contest, driving galaxies further and further away from one another.
The way that we're going to understand better what is this dark energy that's accelerating through the universe today is to go back in time and look at when did dark energy first start to become important? When did we switch from a universe that was slowing down to a universe that's speeding up? And how did that happen? What was the actual history of the switch from slowing to speeding? If you can get a very detailed history of the expansion of the universe, that will differentiate between these different theories of dark energy. And that's one of the jobs that we're tackling right now.
Where will this mighty battle end? A truce or a crushing victory for one side? It all depends on what dark energy actually is. And there are several competing theories. One of the more ominous calls it phantom energy.
Well, there's many theories of dark energy. One of them is that it's this phantom energy, it's called, and that has this interesting consequence that as it's accelerating the expansion of the universe, making it bigger and bigger, this acceleration gets faster and faster and faster. If dark energy is this phantom energy, it's accelerating the expansion of the universe so much that the universe gets bigger and bigger, more rarefied and diluted, and eventually galaxies will start to get torn apart. Even after that, solar systems will get pulled apart, and then stars, and eventually even the constituent atoms and particles that the universe is made of will get ripped apart in what is known as the Big Rip.
But there's one bright spot in this dark and threatening picture. One thing that we know little about, dark matter, may end up being the best tool to study dark energy.
Dark energy is a force that's trying to push the universe apart. Dark matter is trying to clump things together, and it's the interplay of these two things that has led to the formation of the structures that we see in the universe today. And so by understanding how fast the galaxy clusters form and clump together, that tells us about dark matter, but also about how much dark energy was pushing it apart at the same time.